While CNNs are great for modeling and dealing with visual data, RNNs, or recurrent neural networks, were specifically designed for sequential data. Examples are trading signals, so stocks, bonds, and forex, or music, where there is a certain flow. Speech recognition and handwriting recognition are also instances of RNNs, as each consequent word often depends on what you said before. It is probable that the suggestive keyboard on your phone was developed through an RNN. Similar to CNNs, RNNs are an extension on top of the NNs we have seen so far. The specific feature of RNNs is that they have memory. Let's illustrate. We have an input layer, a hidden layer, and an output layer. We forward propagate, but we keep the information from the hidden layer. For the second sample, we forward propagate again, but the hidden layer this time is a function of both the input layer, the updated weights, and the hidden layer from the previous iteration. If we want to design a similar figure to that of deep neural networks, we would have the same picture as before, but this time there are additional weights that lead from the hidden units to themselves. Essentially, these are connections between the hidden units and their own values for the previous inputs. By now, every input target pair was independent. With this new structure, an output is formed by the current input and the hidden units' values from previous forward propagations. Therefore, we must learn their weights as well. If you think about an RNN, you realize that it's basically a deep neural network. The net, though, is not just deep, but extremely deep. This is called unrolling the RNN. If we unroll the added time dependencies, we will end up with a deep feed-forward neural network. While RNNs seem very easy following this short description, they are computationally expensive as they are extremely deep. Moreover, due to the high number of layers involved and their interconnection over time, one must have a very focused approach and a solid understanding of deep NNs before diving into RNNs. Alright, well, I'm sure that you now have a much better idea of what comes next, right? After exploring CNNs and RNNs, it is time to tell you that there are scientific papers combining CNN and RNN networks. But that's an issue to be explored in the future, as it is not well established how the two can work well together. In the next lesson, we will conclude by saying a few words about non-neural network machine learning. Thanks for watching!